Alright, so now we're going to move on to our second video for section 8.5, and it's now going to use the law of sines, and we're going to answer some problems with it. Alright, so the first video, all it was just talking about it, showing you the formula, why it works, how it works. Now we're going to go ahead and actually answer some problems. Alright, so first, before we do that, let's just go ahead and write out the law of sines again. So it's sine of A over A is equal to sine of B over B, which is then equal to sine C over C. And remember, all of these, A, B, and C's, means opposite side to the given angle. Right? So all of these sides, A, B, and C, just means the sides opposite of angle A, opposite of angle B, and opposite of angle C. And we denote those by the lowercase letters. All right, so when we do this, not every triangle is called ABC. So one of the things you could do is you could just, next to the letters that are given to you, say if it was triangle TUV, maybe what you do then, instead of TUV, if you can't remember just that it's the side opposite, then maybe you would have to say ABC, and then just write little a, little b, and little c, just to help you use this formula. You do not have to do that by any means, but it's something you can do to help you with the formula. Right, so here we do have triangle ABC. So the first thing we should do is we should draw it. Right, so we have triangle ABC. It says the measure of angle A is 48 degrees. The measure of angle B is 93 degrees. And it says AC is equal to 15. And then it says, to the nearest tenth, what is the measure of BC? So we want to know for this, what the measure of that side is there. All right, so if you need to, this is triangle ABC, so you can write little a, little b, and little c if you need to. You do not have to do that, but it's something you can do to help you with the formula. All right, now remember, in order to use law of sine, you have to be given at least one angle and the opposite side, which we are here with angle B and side B, 15, and then since we want to solve for this x, which is little a, we need to be given the angle A, which we are. So that means we are going to use sine of A over A is equal to sine of B over B. Now we substitute what we know. Angle A is 48 degrees, so it's sine of 48. A we don't know, that's what we're trying to solve for, so it's x is equal to sine of B, which is then 93 over 15. All right, so the reason why we need to be given the information I was saying before about the angle and the opposite side is when we set this up, all we have now is one unknown, that x. If we didn't have an angle on the opposite side, then we would have two unknowns. So for instance, if we needed to solve for this side C here, we would then say sine of 93b over little b, 15, is equal to sine of C, which we don't know right now, and little c. Yes, we could solve for that angle C, but it's just a little bit more work that we would have to do. But this is what I mean. Sometimes you won't be able to solve for that missing angle measurement C, and you have more than one unknown. All right, so now, remember, sine of 93 actually represents a number, so we could go ahead and we could plug that into our calculator, and sine of 93 is approximately equal to 0.9986. So we're going to go ahead and write this over here, that sine of 48 over x is equal to sine of 93, which was 0.9986 over top of 15. So then we can go ahead and divide that by 15, and that is approximately equal to 0.0066. So we will then have sine of 48 over x is equal to 0.0666. Now remember, when you're doing this, you should always put this in your phone as the answer button. So that way, if you round earlier, then your answer at the end might be a little off. But then here we can multiply each side by x to get x out of our denominator. So now we have sine of 48 is equal to 0.0666. X, and then we will divide each side by 0.0666, and we would get x is approximately equal to 11.16. It said round to the nearest tenth, so that means this final answer is x would approximately equal to 11.2. All right, so that would be our final answer for the side BC. All right, that is using the law of sine. There's going to be a couple more problems that we're going to do with this, and then we'll be finished with this video. All right, so the next problem, again, is going to be now triangle RST. So we have triangle RST. We know RT is equal to 11. We know ST is equal to 18. The measurement of angle R is equal to 120 degrees. And we want to solve for the measure of angle S. So it means we're going to solve for this here. All right, now remember, this isn't an ABC, so if you need to, you can go ahead and write ABC, little a, little b, and little c. And then by doing this, you would see that you have sine of A and its opposite side, and then sine of B and its opposite side. So we can write it out. Sine of A over A is equal to sine of B over B. Angle A, or angle R really in this case, is equal to 120, so it's sine of 120 over top of the opposite side of that, 18, which is then equal to sine of B, which we don't know, but it's really this angle S, so we'll write sine of S over top of the side opposite of that, which is 11. And remember, this actually represents a number, so we can plug that into our calculator. And I'm just going to do that in one shot this time, so it'll be 0.0481 is equal to sine of S over 11. Then we can multiply each side by 11. And then we will get sine of S is equal to approximately 0.529. And then remember, if we want to solve for this angle, what we need to do is take the sine inverse of each side. Angle S is approximately equal to 31.95 degrees. Since it does say round to the nearest tenth, we would round this up, which then means it's going to give us that S is approximately equal to 32.0 degrees. All right, so that's now using the law of sine to solve for one of our angle measurements. One more problem that we're going to do, then we're done with this video. All right, so the problem that we're going to do here is more of a real-world scenario. So it says a ship has been at sea longer than expected and has only enough fuel to safely sail another 42 miles. Port City Lighthouse and Covetown Lighthouse are located 40 miles apart along the coast. At sea, the captain cannot determine the distances by observation. The triangle formed by the lighthouses in the ship is shown. Can a ship sail safely to either lighthouse? So now we're going to go ahead and we're going to draw this triangle out. Actually, rather than drawing it out, I just went and took a screenshot and put it here because we didn't have any of the angle measurements. Sometimes I will give you enough information in the word problem here that you won't be given the triangle, but you'll know what the angle measurements are based on what's provided for you in your word problem. All right, but here we'll just label this A, B, C. So that means that this will be little side C, this will be little side B, and this will be little side A. So it says, the triangle formed the lighthouse is now shown. Can the ship sail safely to either lighthouse? So the only thing that he can do now is sail for 42 more miles. So that means we need to solve for B and A because we need to know, can he go to either port house? So what I'm going to do first is, since this angle is less than this angle here, I know that this side B has to be less than this side A. So that means if he can't sail side B, then he definitely can't sail side A because we know that A has to be bigger than B. So we're going to go ahead and we're going to solve for B first. So the first thing we're going to do, in order for us to solve for this, we're given this side here, which then means we need to know the angle opposite of it. But we're given 70 and 52 degrees, so we can just simply solve, add those together, set it equal to 180 and subtract. So 70 plus 52 will be 122, plus angle C is equal to 180. So then we subtract over 122. So that means the measure of angle C is then equal to 58 degrees. So I know that this is 58 degrees. All right, we can actually solve this problem now without even doing any other work, and we can talk about that in class if you can't identify why this problem is already solved here. All right, it doesn't ask us for any actual length. It just says, can the ship sail safely to either lighthouse? We actually have enough information already provided. All right, but we're going to go ahead and we're going to solve for this angle, this side B. All right, so that means we have sine of C over C is equal to sine of B over B. We'll plug in what we know. So angle C is 58 degrees, so it's sine of 58 over top of the C, which is 40, is equal to sine of B, which we know is 52, over top of little b, which is what we're solving for, which we do not know. All right, now remember, this represents a number, so we can go ahead and plug that into our calculator, which is equal to 0.0212. And now remember, if we want to solve for little b, we then would have to multiply it to both sides. And we get 0.0212b is equal to sine of 52. And then we will have to go ahead and divide each side by 0.0212. And once again, I'm going to say this every time, make sure that you are using your answer button here and not actually rounding it to 0.0212, or else your answer could be slightly off. Which this is then going to be equal to approximately 37.168 miles. And since 37.186 miles is less than 42, we know that this ship can make it safely to the Port City Lighthouse. Right? And all the question says is, can the ship sail safely to either lighthouse? So you can just stop and answer yes now. You don't have to solve for A because it doesn't say can the ship sail to both lighthouses. It just says to either. So we know that the answer is yes because it can at least sail to the Port City Lighthouse. All right, now back to what I said in the beginning. Once we solved for this angle measurement, we actually could have stopped and answered this question. Because since 52 is less than 58, I know that B has to be less than 40. And since it's less than 40, it's got to be less than 42. So we could have stopped and ended it there. All right, now that is it for this question and this video. I know that this video was a little bit longer, but that's it for this section.